Design phase. Dear learners, the database design process is a composition of 5 sequential phases. These are requirements collection and analysis, conceptual database design, selection of database product, logical database design, physical database design. Requirements collection and analysis. The requirements collection and analysis is the originating point of a database design. One must know and carefully analyze the requirements collection and analysis for effective database design. The major activities during this phase are the identification of major application areas and user groups that will use the database system. The study. Existing documents concerning the application are studied and analyzed. Study the present operating environment, if any. The requirements analysis is carried out by a team of experts with the active participation of customer and other stakeholder. The stakeholder are those who have significant impact on system under study. Therefore, joint application design methodology is used for refining initial system requirements. The requirement collection and analysis phase is normally a time-consuming but is crucial to the success of the information system. Conceptual database design. The goal of conceptual database design phase is to produce a conceptual schema for the database that is independent of a specific DBMS. It involves 2 parallel activities. These are conceptual schema design, transaction design. Let us discuss each in more detail. Conceptual schema design. It examines the data requirements resulting from requirements collection and analysis. It produces a conceptual schema. The conceptual schema design is a complete understanding of the database structure, semantic interrelationships, and constraints. Selection of database product. The selection of a database product for database development depends upon 2 important factors: technical, non-technical. Technical. The technical factors are concerned with the suitability of DBMS product with reference of technical issues such as storage structures, access paths support, interface, architectural options. Non-technical. The non-technical factors are concerned with the suitability of DBMS product with reference of non-technical issues such as finance, support of the supplier. However, there are economic and organizational factors also that affect the choice of DBMS. These are economic factors, organizational factors. Economic factors. The economic factors are software acquisition cost. The software acquisition cost includes selected version of DBMS product, other software needed. Maintenance cost. This is the recurring cost of receiving standard maintenance from vendor and for keeping the DBMS version up to date. Hardware. The hardware cost includes new hardware needed such as additional memory, computers, disk drives. Database creation and conversion cost. This is the cost of either creating the database system from scratch or converting an existing system to the new DBMS software. This cost is hard to project and is often underestimated. Personnel cost. Acquisition of DBMS software for the first time by an organization is often accompanied by a reorganization of the data processing department. Positions of DBA and staff exist in most companies that have adopted DBMSs. Training cost. The DBMSs are often complex systems and the related personnel must often be trained to use and program the DBMS. Training is required at all levels including programming, application development and database administration. Operating cost. The cost of continued operation of the database system is typically not worked into an evaluation of alternatives because it is incurred regardless of the DBMS selected. Organizational factors. The organizational factors are organization-wide adoption of a certain philosophy. This is often a dominant factor affecting the acceptability of a certain data, a certain vendor, or a certain development methodology and tools. Familiarity of personnel with the system. If the programming personnel within the organization are familiar with a particular DBMS, it may be favored to reduce training cost and learning time. Availability of vendor services. The availability of vendor assistance in solving problems with the system is important since moving from a non-DBMS to a DBMS environment is generally a major undertaking and requires much vendor assistance at the start. DBMS portability. Many commercial database management systems now have versions that run on many hardware and software configurations. The need of applications for backup, recovery, performance, integrity and security must also be considered. Many database management systems are currently being designed as total solutions to the information processing and information resource management needs within organizations. Logical database design. The logical database design is the process of designing tables and their relationships. This database design is free of any DBMS product and could be easily implemented on any selected database product in lateral stage of design. The logical database design can be achieved by designing tables directly from the detailed description of the system under study without using any modeling tool such as entity relationship model. But it is strongly recommended that entity relationship model shall be used as structured analytical tool which is easily converted into logical database design. Physical database design. Physical database design is the process of choosing specific storage structures and access paths for the database files to achieve good performance for the various database applications. Each DBMS offers a variety of options for file organization and access paths. These usually include various types of indexing, clustering of related records on disk blocks, linking related records via pointers, and various types of hashing. Once a specific DBMS is chosen, the physical database design process is restricted to choosing the most appropriate structures for the database files from among the options offered by that DBMS. These criteria are often used to guide the choice of physical database design options. Response time. This is the elapsed time between submitting a database transaction for execution and receiving a response. Response time is also influenced by factors not under DBMS control, such as system load, operating system scheduling, or communication delays. Space utilization. This is the amount of storage space used by the database files and their access path structures on disk, including indexes and other access paths. Transaction throughput. This is the average number of transactions that can be processed per minute. Transaction throughput must be measured under peak conditions on the system. Performance depends on record size and number of records in the file. Hence, we must estimate these parameters for each file. Estimates of file growth either in the record size because of new attributes or in the number of records should also be taken into account during physical database design.